Hi everyone, in this video I'm going to help you work on some of the problems for 7.2 homework. So let's work on the even problems. You are supposed to work on the odd ones. I'm going to do some of the even problems for you just to show you how to work on these problems. So first of all, for question number 2 that we have y equal to -7 plus cosine of theta minus 110, which we are working in degrees. I wrote the general sinusoidal function here in order to find the values of a, b, c, and d. So as I write here, I can match c with -7. So that means if c is equal to -7, then we have a vertical shift. Because it's negative, we are moving down 7. So right now, I can move the sinusoidal axis to -7. The sinusoidal axis for parent function of cosine, we know that cosine looks like this, and the sinusoidal axis is this axis of x. X-axis is our sinusoidal axis. Now, this is moved down 7. So the first thing that I'm going to do here is to move the sinusoidal axis from here down 7. Let's say, for example, 7 is here. So at y equal to -7, we have the sinusoidal axis of our function. Next, I'm going to find a value. As you see, there is no number here that is multiplied by my cosine. It's basically 1. So I can say the a value is 1. A is 1, and that tells me that the amplitude of the function is equal to 1. When I have the amplitude, I can figure out where are my highest and lowest points. So from the sinusoidal axis, I go one top, which is at -6, and one to the bottom at -8 to find my highest and lowest point, because we know that amplitude is the distance between highest to the middle line or the lowest to the middle line. So I got my highest and lowest points. Next is the b value, and our b value here again is 1 because there's nothing multiplied by this parenthesis here, so it's just 1. So that means the period of the function is the same thing as period of the parent function. Parent cosine has a period of 360 degrees. We are working with degrees, so I'm going to write the same thing, 360 degrees. And from this point, I'm able to find the steps between the critical points. So you just divide 360 by 4, and it's equal to 90. So 90 is the steps or the distance between my critical points. I'm going to find the critical points later. Now let's talk about the last one. D is matching with this 110. So D is equal to 110. And because I have minus 110, that means we are moving right for 110 degrees. And this 110 degrees is going to be our start point, because our function was supposed to start at 0, but now that I'm moving right to 110, that means the function is going to start at 110. So now I can find my critical points. I'm going to start with 110. Let's say it's here, 110. Then I need to go 90 degrees to the right, because the steps between critical points is 90. So 100 plus 110 plus 90 is 200. Plus another 90 to 90 is my next critical point. Again, I add another 90 to that. It will be 380. Next one will be 470. 470. how many points do I need here? 1, 2, 3, 4, 5 for one cycle, because in each cycle we have 5 critical points. So 1, 2, 3, 4, and 5. These are the critical points. So this is for one cycle, but the question is asking us to sketch 2 complete cycles. So I need to go forward and do 5 more of this. So I'm going to add 90 to this. It's 560. I'm going to draw the second one, write the second one with another color to show that we are starting the second cycle. So this is 560 plus 90 is 650 plus 90, 740, and I'm going to add another one here. Plus 90 is 830, and we are done because this point is going to be a critical point for both of the cycles. It's in common between them, and I'm going to show that how it works. Okay, so cosine is a high point, then middle point, low, middle, and high point. So I'm going to start. The first critical point is a high point like this one. So the first one is going to be here. Let's draw with this color. This is the first point. Next, I have a middle point. So the middle point is going to be on the sinusoidal axis. Next, I have a low point. So the next one is a low point. Then a middle point, and last one is highest point. So this is the first cycle. Okay, the next one is going to start from here. We start with the high point, which is we're already on high point. Let's draw this one with another color. Let's do green. So we start from here, then a middle point, then a low point, middle point, and the last one a high point. So this is the second cycle of our graph, and we're done. Okay, now let's work on question number 4. So by looking at this function, I can say y equal to c plus a cosine of v times theta minus d. So I can say c is -1. Okay, and this means that our function is moving down 1. So the horizontal midline or the sinusoidal axis of the function is going to be moved down 1. Instead of being on the x-axis, it's going to be moved down 1. So this is the sinusoidal axis. Next, we have amplitude. The amplitude is 1 because there is no number multiplied by cosine. So I'm going to say amplitude is equal to 1. Notice that the negative that you see here means that we have a reflection over x-axis. So it doesn't have anything to do with the a value. So this is just for reflection over x-axis. The amplitude is 1. So in order to find the highest and lowest point, I need to go 1 up and 1 down. So 1 up from -1 will be 0. This is my highest point. And 1 down at -2 is the lowest point of the function. So amplitude was equal to 1. Next, b value. B value here again is nothing. It's 1. There's no number here. I mean, not nothing. Basically, the b value is 1. That means the period of the function has not changed. Period of the function is 2 pi. Because we are working with radian, I write the period in radian, so it's 2 pi. Now I can find the steps between critical points, and that's 2 pi divided by 4. To find the steps, you just need to divide the period by 4. And if I simplify, 2 divided by 2 is 1, 4 divided by 2 is 2, it's equal to pi over 2. So this is the steps between the critical points. And last, we have the d value, which is equal to pi. So d is equal to pi, and that means we are moving, because it's subtracting pi, we are moving right pi. So this is our start point. Okay, so I'm going to start finding my critical points. We start with pi. Let's say pi is somewhere here. Okay, so this is pi, and then I need to move pi over 2 after that. So see, pi plus pi over 2 will be, I'm going to set a denominator of 1 here and find a common denominator, multiply top and the bottom by 2. It will be 2 pi over 2 plus pi over 2, which is 3 pi over 2. So the next critical point is here at 3 pi over 2. The next one, I need to add another pi over 2 to this one. So here, just plus pi over 2 will be 4 pi over 2. So I'm going to write 4 pi over 2. You can also simplify this as 2 pi, because this 2 and this 4 will go away, but this is okay if you just keep it like this. For the next one, add another pi over 2, so it's 5 pi over 2. And another one, 6 pi over 2. You can simplify 6 pi over 2 is 3 pi. Okay, so this is the first cycle. And for the second one, because I have 1, 2, 3, 4, 5 points. In each cycle, we have 5 critical points. For the second cycle, I'm going to add pi over 2 again. So 7 pi over 2. Then we have 8 pi over 2. Then 9 pi over 2. And the last one, 10 pi over 2. Okay, now I can start graphing my function. Cosine looks like this. It's high, middle, low, middle, high. Okay, so I can follow the same pattern, but notice that we had a negative here. This negative is reflection over x-axis. That means we need to flip this. Any high point will be a low point, and any low point will be a high point. So here I start from pi. Instead of putting a high point here, I'm going to do a low point. So the first one is a low point. Middle point is going to be the same, because even if you reflect it, nothing will change. Then instead of a low point, I'm going to have a high point, middle point, low point. Then high point, middle point, low point, and middle point. Oh, I apologize. I made a mistake here. So after, let's go back here. After this point, which we had a low point, then we have a midpoint, then a high point, midpoint, and low point. So I apologize. I made a mistake here. This is the right one. Now I can start graphing my function. And this is the second cycle. So this is how we graph this. Okay, so I'm going to leave the rest for you to work. Just keep in mind, if you are working with a sine function, if you're given a sine function, the general pattern for sine, the general pattern for sine is like this. The parent function looks like this. So it has a midpoint, high point, mid, low, and midpoint. So this is the general pattern for sine, and for cosine is high, mid, low, mid, and high. Okay, have a great day.